Carbohydrates are molecules that are very often used for energy. So these are used by cells, and you could also say organisms, as an energy source. And so since these are going to be so important to the cell as an energy source, we do want to understand how to recognize their structures. Some other terms that we could use for carbohydrates, sugars is very often used, so that's kind of a layman's term for carbohydrates, and saccharides is another one. So those all pretty much mean the same thing, and we'll specifically use the term carbohydrate. Now, when we start talking about carbohydrates, they do come in three different forms. So these can come as monosaccharides. We can have disaccharides. And then there's also polysaccharides. So with all of these, the only real difference between them is just how big they are. So hopefully you notice these prefixes here. Mono means one, di means two, and poly means many. So these are really terms that describe how many monomers or subunits make them up. So when we're talking about monosaccharides, these have one, I'm going to say monomer, or again, we could call this just a unit. Disaccharides are going to have 2 units. And then the polysaccharides are going to have 3 or more units. And usually with the polysaccharides, we're really talking on the order of thousands of units. We're going to spend most of our time in this little tutorial talking about the monosaccharides and how to recognize their structure. Because if we can recognize the structure of just one, then hopefully we can recognize the structure of just taking 2 of those and hooking them together, or 3 or more of them and hooking them together. So with monosaccharides, just to go through some of the basic things that we're going to look for in their structures, first off, these are going to contain 3 to 7 carbon atoms. And so these are relatively small molecules. I'm going to begin over here on the side with drawing the structure of a monosaccharide, and I'll add to it as we go along. These 3 to 7 carbon atoms are going to be kind of right in a row. So I've just drawn them vertically. You could draw them horizontally as well. And then the next thing that we're going to have is we're going to have one carbonyl group. So if you've learned your functional groups, and hopefully you have, you will know that the carbonyl group is just like this. So we're going to have one of these carbons that we've already drawn is going to have a double bond to an oxygen atom. Now this could be located on any one of those carbons. There are different names for the monosaccharides depending on exactly where it's located at. So whether it's located on one of the end carbons or whether it's located in the middle. For our purposes, I'm just going to draw it right now coming off of this one in the middle. So we always have one carbonyl group. Now another thing that we always have is that every other carbon, and by every other carbon, I mean the carbons that do not have the carbonyl group, every other carbon gets one hydroxyl group. And hopefully you remember what the hydroxyl groups look like. They are our OH groups. So you could point these off in either direction. So I'll kind of draw them in both ways so that you can see them. The only other thing we have to remember here for monosaccharides is that we're going to fill in with hydrogen atoms to give every carbon 4 bonds. Okay, so we could, for this top carbon, we could add in 2 more hydrogens. The middle carbon does not need any because we can already see 4 lines coming off of it. And then this carbon on the bottom is also going to get 2 hydrogens. So that right there is the structure of a very simple monosaccharide. We have 3 to 7 carbon atoms. We're going to have one carbonyl group coming off of one of the carbons. Every other carbon is going to get a hydroxyl group, And then we're just going to fill in with some hydrogen atoms so that we ensure that every single carbon is going to have 4 bonds coming off of it. The monosaccharides get just a little bit larger than this one, but not much. So that would be what we would call a linear monosaccharide. The monosaccharides are not always linear structures. So monosaccharides can be linear, like we just saw, or we do have times when they are going to be ring structures or cyclical structures. This is going to happen a lot of times with the larger ones, so with the larger carbs. So in this case, we're talking about the ones that maybe have 6 or 7 carbon atoms. If we look at an example of this, when they do form rings, the rings that we're going to get are either going to be, these are either going to be hexagons or pentagons. And so if we look at a simple one here, these ring structures, they will have an oxygen embedded in the ring somewhere. So that is what we see with this one. And I'm drawing this partially as a skeletal molecule because that will eliminate a lot of those extra details that are just going to kind of cloud it up. And so this is what we've got. If I add in some of my other hydroxyl groups that are going to be here. Okay, this, just make sure that I've got them all. Okay, so this looks good, what I've got right here. So this is going to be also a monosaccharide. Clearly it looks different from the ones that we just had. If we just go through and we label a bit more of this so that hopefully you can see that we do have all the necessary components here. I'm just going to draw in my carbons on all of the little corners and points. Okay, so if I were to count up my carbons, I've got 6 of them. And then if I added in the extra hydrogens that are not being shown, I would have 2 coming off of that carbon. This carbon here has plenty. This one gets 1 more. This one gets 1 more. This one gets 1. And this one up here is going to get 2. So if I go through here and I count up all of my hydrogens, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I've got 12 hydrogens. And then the only other thing I have left in here is that I do have some oxygens. And my oxygens, there's going to be 6 of those if you go through and count them up. So what I've written right here, this would be the chemical formula. And when we're looking at the chemical formula of any monosaccharide, you end up with some multiple of CH2O. And so that is the basic formula right there. So if we look at this one, if you were to factor out a 6, you would end up with this formula right here. Now the part that we talked about previously with the linear ones, the part that does look like it somewhat disappears when we go to the ring forms is that we don't clearly see the carbonyl group anymore. And that's because the carbonyl group kind of disappears when we form the ring. And this is kind of the remains of it. So these structures, this linear form and the ring form, these are actually kind of continuously flipping back and forth between each other for these larger ones, the ones that have 6 carbons or 7 carbons to them. So this molecule right here might be in a ring form for just a moment in time, and then it may flip to form the linear form of it. So if we were to draw this in linear form, just remember we're going to have our 6 carbons in a row. I have my other one up here. You would have 1 carbon that is going to have that carbonyl group. And then we're also going to have lots of hydroxyl groups coming off of all of the others. And at this point in time, I'm just kind of randomly pointing them in one direction or the other. And then the only other thing we would have is we would have enough hydrogens to ensure that every carbon gets 4 bonds around it. So if you're trying to identify molecules as whether they are representing monosaccharides, Again, the keys that you want to look for is you want to look for just the presence of the three elements that we've talked about, carbon, hydrogen, and oxygen. We want to have a small number of carbons, somewhere between 3 and 7. We want to have one carbonyl group if we're looking at a linear molecule. If we're looking at a ring molecule, then we want to see one oxygen embedded inside that ring. And then we also want to see lots of hydroxyl groups. If we go through and we come up with the chemical formula or the molecular formula, we do want to end up with some multiple of CH2O.